Okay, lesson 9.3, we are talking about geometric sequences. Now, what was it we talked about yesterday? Yesterday was arithmetic, yes? And what was true about an arithmetic sequence? Okay, we were consistently adding the same number to get to the next term, right? It was always adding the same number. Okay, geometric sequence is a sequence where the ratio between consecutive terms is a constant. So when we were adding, it was called the difference. Here we're going to talk about the ratio is a constant. Any idea what that's leading us towards? Okay, fractions can be involved. What mathematical operation are we talking here? Multiplication. Okay, officially multiplication. Now, did I hear and division thrown in there? Yes, we're going to talk division. I have to be careful how I say that, though, because technically a geometric sequence is in terms of multiplication only. We'll correlate the division in there, don't worry. But technically, when we talk about this, we are specifically looking at multiplication. Okay, so the ratio between consecutive terms is a constant, means you are multiplying by the same number every time. Okay, we're going to call it the ratio, and instead of having a common difference today, you have a common ratio. Instead of having to give me D today, you have to give me R. Now, a couple of things are staying the same, of course. The first term is still a sub 1. The nth term is still a sub n. An example here, 2, 4, 8, 16, 32. I think we had the same sequence somewhere in yesterday's notes. What do you notice about 2, 4, 8, 16, 32? Okay, multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So that is an example of a geometric sequence because you're multiplying by the same number every time. Because we're multiplying by 2 every time, that tells me my R, my common ratio, is 2. And A1, what do we know about A1? A1 is 2 because my sequence started with a 2. Okay, so that's some of the basics about geometric sequences. Like yesterday, we're provided a recursive definition and explicit definition. Just like yesterday, just of obviously slightly different definitions. So notice today these of course are the definitions for a geometric sequence. For the recursive, you will notice that a recursive, it starts off the same. A of 1 equals A, which if you recall from yesterday, basically we just say A of 1 equals some number, right? Your first number. And then the other thing you have to be able to fill in is R. So it's, for our actual definition, A of n equals A of n minus 1 times R. Do you remember what A of n minus 1 represented? The previous term? Okay. Past, I get it. Previous term. So yesterday our recursive was A of n minus 1 plus D. Today it's times R. Now, explicit, the one that we'll probably use more, of course. A of n equals A of 1 times R to the n minus 1. Again, you have to be able to fill in A of 1 and R. The n minus 1 in the exponent will stay as is, and that's A of n for you. Okay. Got some basics in there for you, right? Let's start off with practicing and figuring out what's geometric, what's not geometric. So in example 1, is the following sequence geometric? If so, what is R? Not what is D, what is R today? So example A, 3, 6, 12, 24, 48. See that connection? 3 times 2 is 6. You should keep checking though, right? Don't just stop. Check them all. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. Did it work all the way through? Yeah, it worked all the way through. So, is this sequence geometric? Yes, because we're multiplying by the same term every time, right? Yesterday, if you were adding, it was arithmetic. Today, if you're multiplying, it is a geometric sequence. If it's geometric, what is R? What did we keep multiplying by, right? We multiplied by 2, so R is 2. Okay. B? 3, 6, 9, 12, 15. What do you notice about 3, 6, 9, 12, 15? Adding 3. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. What does that tell me? Okay, if we want to revisit yesterday, because we added the same number every time, this officially is arithmetic. Now, did they ask that? No, still good to talk about. Is it geometric? Have you checked? And here's what I'm going to say. Okay? The adding was the obvious part, so is arithmetic. It's probably not geometric, but there are rare cases where it can be both arithmetic and geometric. So don't just automatically rule it out. Kind of check yourself. And here's what I'm going to say. Okay, look up. How do I get from 3 to 6 in terms of multiplying? Multiply by 2. How do I get from 6 to 9 in terms of multiplying? You can, but the key is not by 2, right? Like you can multiply. It'd be 6 times 1.5 would get you 9. But at that point, what does that tell me? Now I can officially say this is not geometric. Okay? So that's, check your multiplication. You check the first one. If the next one doesn't work, it'd have to be 6 times 2 is 12. That skips over 9, so that doesn't work. So this is not geometric. Maybe a little overkill on my part, checking the geometric part after we discovered it was arithmetic, but I want you knowing what to look for. Okay? You get your easy lead in there, didn't you? Ready to try C? 3 to the 5th, 3 to the 10th, 3 to the 15th. So we have to somehow decide whether or not this is geometric. Natalie? What? Okay, and why do you say it is geometric? Okay, so this is what someone in my morning class did too, and it's not what I'm gonna do. Okay, Okay, it's not what I'm going to do, but that doesn't mean I'm not willing to listen, and it doesn't mean it doesn't get you to the right answer and it doesn't work. Okay, kind of like over here when we were working on the last lesson. I didn't write an equation. It got me there, though, didn't it? Okay, so Natalie said she used her calculator, and she found out what 3 to the 5th, 3 to the 10th, and 3 to the 15th were, and she worked with it that way. And she's claiming it is geometric. I'm not going to argue, but I'm going to do this without touching a calculator. Okay? What are you going to say, Sierra? By what? Not 1 to the 5th. Okay, so let's review some exponent rules here. So the idea here is 3 to the 5th times what gives me 3 to the 10th, right? That's what I'm trying to figure out. And so if I'm trying to figure out 3 to the 5th times what is 3 to the 10th, how do we multiply when exponents are involved? You add the exponents as long as the bases are the same. So 5 plus what is going to be 10? 5. So does this make sense? You have to dig into those exponent rules. 3 to the 5th times 3 to the 5th. As long as the base is the same, you keep the base the same and add the exponents. 5 plus 5 is 10. Now, you do technically need to check, does that work the next time? So the next time it's 3 to the 10th times something equals 3 to the 15th. Does that work? And it does, because 3 to the 10th times 3 to the 5th, keep the 3 the same and add the exponents. Okay, so 3 to the 5th times what is 3 to the 10th? 3 to the 5th. 3 to the 10th times what is 3 to the 15th? 3 to the 5th. Is this geometric? Did I multiply by the same thing repeatedly? I did. So this is geometric. If it's geometric, what is R? I'm going to say 3 to the 5th. Natalie's going to say 243 back there. I mean, if it's on a test, like a mine or something, it's equivalent. Okay? I don't know if Math Excel would give you anything exactly like this. And who knows what kind of answer they would want on something like this. But this is a good one to get your brains thinking. Okay? And I know some of you will say that in order to find what you're multiplying, you go backwards and you divide. That would work here as well. And that I can do 3 to the 10th divided by 3 to the 5th. Command subtract. Okay, let's try the second row of these. 2, negative 4, 8, negative 16. Thoughts? What's the alternating positive negative mean? We're going to be multiplying by a negative, yes? So that's one good thing to notice. And then, honestly, if you drop off the negatives, haven't we already had this pattern? What do you know about 2, 4, 8, 16? Multiply by 2. So if we put that negative back in there, let's check it out. 2 times negative 2 is negative 4. Negative 4 times negative 2 is positive 8. 8 times negative 2 is negative 16. Is it geometric? Yes, we just multiply by the same thing, right? Same number. So yes, it's geometric. If so, what is R? Or what did I multiply by? Negative 2. Make sure you state the negative 2. Not just 2, negative 2. 1, 5, 9, 13, 17. So what can we identify here? Okay, we see the adding 4. 1 plus 4 is 5, plus 4 is 9, plus 4 is 13, plus 4 is 17. What does that tell me about this sequence? I at least know the sequence is arithmetic. Not technically the question, but I can't remember if it's this lesson or another lesson. There's some place where you have to answer, is the sequence geometric, arithmetic, or neither? Or maybe it says or both or neither. So, okay, did you check the multiplication? 1 times what is 5? 5. 5 times what is 9? Not 5. Appropriate answer there. 5 times something is 9. It's not 5, which is the key that tells me this is not geometric. Okay.
Pardon interruption at this time. We need all 6th graders to report quietly to their testing rooms. Please enter the testing room quietly. Thank you.
Okay, let's look at F. F is a really good one to look at, and F is going to help us with what I said at the beginning about I need to focus on talking about multiplication today. Not the division doesn't tie in, but I have to remain my focus on multiplication, and I'll explain why here. Okay, 5, negative 1, 1/5, negative 1/25. What kind of thoughts do we have on this one? Decimals, fractions, something there. Sarah? Okay, so first of all, do we agree that it's going to have to be a negative? Yes. We could get that out of the way, right? So then it really just comes down to looking at the numbers. Natalie, what are you going to say? Divided by negative 5? Okay, so let's look at this. How do we get from 5 to negative 1? And if we use, I'm going to use Natalie's division for a moment. We'll come back to the multiplication here, okay? But 5 divided by what is negative 1? Negative 5. Is that a piece that you guys can figure out? Because I'm guessing more of you are going to relate to Natalie right now than Sierra for the moment. Okay, maybe I'm wrong, but I'm just going with what the norm is, okay? Ezra's going to break the norm, of course. I should have known. Okay, now, okay, on this next one, negative 1 divided by what is going to be 1/5. Does that make sense if we still say 1 divided by 5 is 1/5? Yeah, I do that when we're solving equations and stuff sometimes, right? You guys want to go to that decimal, and I say, no, I'm just going to say 1 divided by 5 is 1/5. So in this case, negative 1 divided by, negative 1 divided by negative 5 gets you 1/5. Now we get to that one, and you guys are probably saying, I'm just going to kind of assume. Okay, that's fine. But here's the deal. If you went this way, you just said divided by negative 5. Okay, so that's enough to tell me, is this geometric? Yes, it is, because multiplication, division, they relate, yes? Kind of like addition, subtraction relate. So because they relate, I do know that this is geometric. Now, here's what I don't know at this point. I don't know R. R is not negative 5 because R is whatever you multiply by over and over and over. Okay? And so that's why I say I have to talk multiplication. Because if I start throwing in division, then we're going to get our R values wrong. So this is where you have to go back. Dividing by negative 5 is the same as multiplying by what? And this is where the negative 1/5 comes into play. Of course, it's still negative, but remember keep, change, flip, or multiply by the reciprocal? Dividing by negative 5 is multiplying by negative 1/5. Or if we forget the negative for a moment, dividing by 5, well, that's dividing by 5/1, multiplying by 1/5. And so my R value is what? Negative 1/5. Okay, so that's one way to look at it, is to think like Natalie did that, okay, I'm dividing by negative 5, but then I have to turn that to multiplication. Does multiply by negative 1/5, does that make sense for these last two? That's where it really makes sense. 1 times 1 is 1. 5 times 5 is 25. So that's a place that it really makes sense if you ask me. Yes? Technically, I would say it doesn't matter if you put fraction or decimal. Math Excel might have a different opinion. You know, for me, when you said negative 2/10 or negative 0.2, that is equivalent to negative 1/5. Now, my guess is you got the 0.2 because you were using your calculator to figure some stuff out. Okay. And that works as well. Okay. Did you guys hear what she also said? If you don't know how to multiply to get from 5 to negative 1, have you figured out you guys can go backwards? What is negative 1 divided by 5? It's that negative 0.2, which so happens to be negative 1/5. So several different ways we can talk about these. Okay? None of what we've said is wrong. They're all good ways to talk about. Okay. Here's what I'm going to say. That is where my morning class got to. That is kind of a good stopping point before we go into the next section. So, tomorrow we will pick up in example 2 where we'll be analyzing geometric sequences. And so we'll do that section and we'll work through the back. Okay? Homework will not be due until Friday. I had to think about what today was. Homework will be due Friday. So we'll finish notes tomorrow. Homework will be due Friday. Even if you're not here due to field trip, you need to have the homework due ready to go on Friday, please. So make sure you get it done. Just a second.